And another thing we need to look at is bearing and distances using scale drawing. How do we calculate the bearing and distance of places using scale drawing? When we get to senior class, we are going to use trigonometry. Okay, so as I was saying, bearings and distances using scale drawing. We have an example here. Say ship sails 20 kilometers from A on a bearing of 42 degrees to point B and a further 22 kilometers due east to arrive at C. Okay, so in this case, when they say from A, that means A is a reference point here. The other one, the bearing of B from A is this angle given to us here, which is 42 degrees. So every bearing question should start with a cardinal point. I will draw a cardinal point and call it point A. And this is my point A. Now from point A to point B, B is on a bearing of 42 degrees from A. So we need to get angle 42 on this line. Remember that bearing measures angle from north in a clockwise direction. So we're going to measure angle of 42 degrees from this north pole in a clockwise direction using a protractor. Since it is scale drawing to the right place, it 42. 42 is right here. Look at 40 here. Let me use this. Look at 40 right here. Look at 40. We need to, since we are coming in the clockwise direction, we are measuring from this, the lower reading on the protractor. That's what I'm looking. So if here is 40, 42 is somewhere here. Let me use this guide to get it. This is my 40, and 42. 42 is equivalent to 138. Good. That is 42 right there. So I'll place a mark there, then connect that point to point A. That is bearing of 42 from point A, 42 degrees from point A. That is, this angle like this is 42 degrees. And they give us a distance of 20 kilometers, and we are told to use 1 centimeter to represent 5 kilometers. That means this 20 kilometers is equivalent to 4 centimeters. That is 20 divided by 5. In other words, from this point A to point B should be 4 centimeters based on the scale. So from point A to, I'm going to measure a distance of 4 centimeters. Anywhere my 4 centimeter ends, that is point B, 4 centimeter here. This is going to be very small. The diagram is going to be very small. 4 centimeter ends there. So when this should get to this very point, which is point B, it change direction and move a further distance of 22 kilometers due east. So let's put another cardinal point on that point B. That is point B there. So this is point B. Let's label it point B. And since the ship move from point B, look at it, a ship says 20 kilometers from A on a bearing of 42. This is the 42 here. And a distance of 20 kilometers, 20 divided by 5, because of the scale given 1 cm is 5 kilometers. That is 20 divided by 5, which is 4 centimeters. 4 centimeters is equivalent to this 20 kilometers. So we measure a distance of 4 centimeters from point A. It ends here, which means this is our point B. The distance between A and B is 20 kilometers, which is equivalent to 4 centimeters based on the scale. Now, when the ship got to point B, it changed its course of movement. It was moving like this before, it represented by this line. But when it gets here, it changed the course of movement, the direction, and moved towards east. Remember the cardinal point. This is north, south, west, and east. So the ship now begins to move straight from point B and we move a distance of 22 kilometers. Again, we need to convert based on our scale. That is 22 divided by 5. Let's use the calculator. 2 divided by 5, 4.4. We need to measure a distance of 4.4 centimeters from point B. Anywhere that ends, that is point C, which is 4 centimeters, 4.1, 0.2, 0.3, and 0.4 ends here. So our point C is right. And now clear this extra line here. And then the question says measure AC, that is the line connecting this point A to point C. Let's use a ruler to connect the point. And there you have it. And now to measure line AC, AC is 7.6 centimeter. AC equal to 7.6 centimeter. But based on the scale, they say, and the actual distance, find the actual distance from A to C. Our 1 centimeter represents 5 kilometers. Therefore, 7.6 centimeter will be 7.6 times 5 kilometers. 7.6 multiplied by 5. That is 38. 38 kilometers. Then next question B. A is the diagram itself, so B is the AC, which we have just done. Then question 6. What is the bearing of C from A? C from A. Use a protractor. C from A. Look at point C here. And they want us to get the angle. Let me use a different color. C from A is this angle from North Pole until we get to the line C. This line connecting point A and C. So how do we get that? We need a protractor. Angle here, that is 70 degree. 70 degree approximately. Look at what I'm reading. This base, the measurement down. Since we are coming in a clockwise direction, we are taking the reading down. So that this angle here, which is this line from North Pole to this line AC, is the bearing of C from A. Place your protractor in a way that the baseline of the protractor is exactly on this horizontal on this vertical line, the North Pole, this vertical line, look at it, and also the intersection of the baseline of the protractor and the 90 degree of the protractor must be on point A, the vertex here. So look at it and show this, which is 70 degree. Look at it. So bearing of C from A is 70 degree. Next question C. Bearing of C from is equal to 70 degree. And the last one, Mr. D, say what is the bearing of A from B? A from B, A from B. A from B, let me use a different color. Starting from the North Pole on point B, we go until we meet the line connecting point A and point B. That angle is what they are asking us to measure. And that angle is made up of this 90 degree here, that is 90 degree there. And there's another 90 degree in here also, that is 1991 80. Then this tiny angle here, let's measure it and then add it to 180. That will give us the bearing of A from, let's measure the tiny angle in this angle here. Let me represent it with red. That angle there, we need to get it and then add it to this 90 here and this 90 here. 1990 is 180. So place a protractor there and measure that tiny angle using the horizontal line as a reference line. So in this case, we are reading from, let me place it like this, so this will be easier for me. We are reading the upper measurement in this case from this point. Look at the angle we are measuring. This angle here, this angle like this is what we want to read. Let me use this to get accurate measurement. Starting from here until I get to this is here, that is 40, 45 approximately. This angle here is 45. So 45 plus 180. I hope you understand what I just did. I'm measuring this angle represented in red. And so I have to use this line as the reference line and then measure like this. You can see this line is the measurement now. This one, that is 45 degrees. 45 degree added to this 90 here, this 90 here, and this 90 here. 90, that is 180. Then 180 plus 42 plus 45 is 225. So the bearing of A from B is 225. That is question 2. Bearing A is equal to 225. We have another one here. It says a vessel sails from port B to a harbor H on a distance of 7 kilometers, a distance of 7 kilometers on a bearing of 306 degree. It then sails a further distance of 11 kilometers on a bearing of 70 degrees to arrive at N. Using a scale of 1 centimeter to represent 2 kilometers, draw an accurate diagram showing the location. So the vessel is sailing from where? From port P. So port P is our reference point. You draw a cardinal point and call it port P. This is port P. Then the vessel sails to a harbor H, a distance of 7 kilometers on a bearing of 306. And the bearing is based on scale drawing. You can't get 306 from the protractor. So what are we going to do? We know that the total what's it called? The revolution. That's the whole of this quadrant is 360 degrees. So I need to get the acute angle from 3 OCs by subtracting these 3 OCs from 360 degrees. 360, based on normal, whatever, here is, remember that bearings starts from North Pole and then in the clockwise direction. So 90, 90, 90. That means 306 should fall on this fourth quadrant. So I will need to get the remaining angle here, the acute angle. And to get this, I need to subtract these 3 OCs from 360 degrees. Let me explain again. If we go complete revolution from this first quadrant, starting here, all the way like this, is 360 degrees. Since we can't get these 3 OCs directly from the protractor, that's why we're doing that. So using that, our 3 OCs should fall into this quadrant so that 3 OCs is coming like this. Meaning this remaining angle here, to get it, we need to subtract 360. We need to subtract 3 OCs from 360. 10 minus 6 is 4. This remains 5. 5 minus 0. So 54. This angle here is 54. So it is this 54 degree that we're going to measure using our protractor. So place your protractor and measure 54 from the North Pole, but going towards the left-hand side, based on what I just explained. Look at it. We measure bearing like this. The angle given to us is 3 OCs. So the whole of this now is the 3 OCs, right? From here to this line, that is our 3 OCs. To get this remaining one here, we need to subtract these 3 OCs from 360. And 360 minus 3 OCs is 54 degree. So 54 degree. So how do we get that? We are measuring from the North Pole towards this left-hand side. That is what I mean. So I'll turn it like this. And 54 degree. This is 50. Then 54 is 54 degree. And I'll place a point there. That's 54 degree. Place a line there, connecting that line to. Okay, so that is 54 degree, which is equivalent to 3 OCs. That is coming like this, coming like this. It's 3 OCs. That is what they want us to get. Okay, now this is how about H. Then they say the distance between port P and harbor H is 7 kilometers, and we are using a scale of 1 centimeter to represent 2 kilometers. That means we need to divide this 7 kilometers by 2, which is 3.5. So we'll measure from point P up along this line, anywhere 3.5 ends. That is your harbor H. 3.5 ends here. Our harbor H is right there. Let me use a different color so you can show 3.5. It's right there. Let me remove where I wrote my H initial and place it here. Now, from point H, it then travels on a bearing. It says a further distance of 11 kilometers on a bearing of 70 degrees. 70 degrees, need to put a cardinal point there on harbor H. Then it's harbor H. And from this harbor H, it travels a distance of 11 kilometers on a bearing of 70. Bearing of 70. Remember that bearing goes where? From the North Pole to measure 70 degrees from this vertical line here. So using a protractor, 70 degrees, we are coming from the North Pole. Remember, if 70 is right, that is 70 degrees. I'll put a point there, a point there, and then that point to point or to harbor H. Okay, that harbor H right here, about the extras. Then they say the distance from harbor H to this very point is 11 kilometers. Based on the scale, 1 centimeter is 2 kilometers. So 11 kilometers will be 5.5 centimeters. We measure from this harbor H on this line, we measure 5.5, anywhere 5.5 ends. That gives us the final destination of the vessel, which is point N, 5.5. I need to go, that is 5.5 right there. And that is point M. And finally, we need to connect this point M to the starting point, which is point P. Okay. Now, what are we to calculate? So using a scale of 1 centimeter to represent 2 kilometers, draw an accurate diagram showing the location. That is question A answered. And question B, so what is the distance of the vessel from its starting point? From its starting point. It started from point B, remember? And then it's at this point right now. So it's asking us to measure the length of this line. This side is 5.5 centimeters. I forgot to write it based on the distance there, which is 11 kilometers. This one is 3.5 centimeters, 3.5 centimeters. We need to measure this line to represent the distance from the starting point, 4.6. Starting point, the distance is 4.6 centimeters, 4.6 cm. Now, based on the scale, 1 centimeter is 2 kilometers. So 4.6 centimeter will be 4.6 times 2 kilometer, which is 6 times 2 is 12, right? 2 carry 1, 2 times 4, 8, 8 plus 1, 9, 9.2 kilometers. The distance of the ship, the vessel from the starting point. And then the last question says, what is the bearing of the vessel from the harbor? The vessel is at point N right now. This is the vessel right here. And they're asking us to measure the bearing from harbor H. Look at harbor H here. So what they're asking us to find is this angle here, this angle. Remember, bearing is the angular distance measured from the North Pole. So the line connecting the vessel to harbor H is this line here. So the angle that that line makes with northern pole, this vertical line, is the bearing of the vessel from harbor H. So place a protractor there and measure that angle, and that is 70 degrees. Then the bearing of the vessel from from the harbor is 70 degrees. And we have the last question here. It says the figure below shows an aircraft flies from its base B and back. It's not the last, second to the last, rather. Then what do they want us to do here? The question is not complete. Let me check the source of that question. Okay, so the question says using a scale of 1 centimeter to represent 50 kilometers, using a scale of 1 cm to represent 50 kilometers, make an accurate scale drawing of the figure, make accurate scale drawing of this, and then that's question A. Question B, find the actual distance BD, find actual distance BD. Then question C, find the bearing of D from B. Find the bearing of D from B. D from B. Okay. We are to use a scale of 1 cm to 50 kilometers. Now starting with this line here, we'll roll a straight line, a vertical line. We represent that line here. And place a protractor on that line and measure an angle of 162. Let me make a reference on that line first to form my complete cardinal point. So on this cardinal point, we get angle of 162 degrees. We are starting from this up part here. So 162 is right here. This is 160 here. 162, manage it. This is 162.3 actually. 162 is equivalent to 18 from this side. Now this guide is measuring, we are using the reed protractor. You won't bother yourself, but you can easily read off 162. So this is 162. We place a ruler there, connect that point, and then the distance is 200 kilometers, and we're using 1 cm to 50 kilometers. So 200 will be 200 divided by 50, which is 4 centimeters. So we measure 4 centimeters from this reference point, this cardinal point, anywhere the 4 centimeter ends, that gives us the point C. So this point C is what we want to represent. 4 centimeter is right here. Let's use a different color. That's 4 centimeter. Is it showing at all? It's manageable. So I'll put a cardinal point there also. Need a vertical one also. Okay, so this is 4 cm, which represent 200 kilometers. The angle here is 162. Okay, now from point, this is point B now. Why this is point C? From point C to point D, the bearing is 260 degrees. And we cannot get 260 using a protractor. That means we need to apply some logic there. Let me remove this extra line. So the logic we are going to apply here is if we have this down, we know that this and this is 90 degree. 90 plus 90 is 180. So if I have something like this and my line is coming like this, if here is 90, here is 90, and if it ends here, for example, that would be 270, but it ends here. As from here all the way like this is 260 as shown there. So to get this tiny one here, that will be 260 minus 180. Since this straight line is 180. So to get this tiny angle, that will be 260 minus 180. From a calculator, 260, 260 minus 180 is 80 degrees. So it's 80 degree we are going to measure starting from this vertical line. I hope you understand my explanation here. Let me explain again. This angle here, as shown on this diagram, is 260 degrees. That is from here to here is 260 degrees. There is no way you can get 260 with a protractor. Then we know that if I drop a vertical line like this, then drop another horizontal line like this. Here is 90, here is 90. So if all the way like this to this very line is 260 degrees according to the question, and this side is 1990, then what will be this remaining one? That is 260 minus this 290 here. That is 1990 is 180. So 260 minus 180 will give us this remaining angle here. And is that remaining angle we can measure from the protractor, which is 80 degree. So from this vertical line, we will measure 80 degree towards the left hand side. So we are going to turn the protractor like this. Then we are measuring from down in this case, because the angle we are interested in is coming. I shouldn't have cleaned this off. Okay. The angle we are interested in, oh no, the angle we are interested in is this angle here. That is from this south pole to this very point. We can get that by subtracting this 260 and 180 from this 260. Because this straight line here, 1990 is 180. So the remaining one, we can get that by subtracting this 180 from the whole of this angle, which measure all the way to this point. And based on calculation, it was 80 degrees. So 80 is right here. Let's adjust it a little. That is 80 degrees right there. Starting from this point, we place a mark there. With a ruler, we connect it to point C. Now, with this angle like this, that is 260 degrees. Now that we know that, now what is the distance here? It is 360. 360 divided by 50. Based on the scale given to us, 1 centimeter is 50 kilometers. So to get the equivalent in centimeter for the length of this line, we divide 360 kilometers by 50 kilometers. 360 divided by 50, 7.2 centimeters. So from point C, we are going to measure the length of this line anywhere 7.2 ends. That will give us point D. Use a different color there. This is 7, so 7.2 here. That's too much. 7.2. And remove it. And also place your cardinal point there. And from that point, now connect it to point B to complete the diagram. Right? Remember this point D. And this line is 7.2 centimeter. That completes the diagram. Now, how do we get what are the questions given? First of all, question A. So using a scale of 1 centimeter to 50 kilometer, make an accurate scale drawing. This is the scale drawing. Then question B, find actual distance BD. Distance BD is the length of this line. So let's measure that line. That is 8, it's now the 7.9 centimeter. 7.9 centimeter distance BD. It is 7.9 centimeter. Now based on the scale, that is 7.9 times 50 kilometers. And 7.9 times 50 is 395 kilometers. 95 kilometers, the distance of B to D. And then the last one is find the bearing of D from B, D from B, D from B, D from B. Let's get this angle. Look at all the way like this. Is the bearing of D from, and how do we get that? This straight line is 180 degree. And with protractor, we can measure the inner angle. Let me represent it with a different color there. This inner angle. Since my 180 ends on this vertical line, this red vertical line. This side like this is 90, and this side is also 90. So 90, 90 is 180. We will get this inner angle, then add it to 180. That will give the bearing of D from B. Place your protractor like this, then shape this to lie on this line. That is 50 degree. Now 50 degree plus 180, that is 230. So bearing of B, I mean D from B rather. Bearing of D from B is equal to 230 degree. And then the last question for the day, it says an aeroplane flies 400 kilometers from a point O on a bearing of 25 degree to a point, this is degree, I forgot to raise it to the power of whatever, to a point X. And it then flies 700 kilometers on a bearing of 80 degree to point Y. Using a scale of 1 centimeter to represent 100 kilometers, draw accurately the position of the point. Then find the distance of y from O and find the bearing of y from O. Okay, O is a reference point here because the aeroplane flies from point O. So we're going to draw a cardinal point and call it point O. So this is point O. And then from that very point, the aeroplane flies on a bearing of 25 degree. So measure 25 degree from that point. And remember that we have to measure from North Pole in the clockwise direction. So we turn the protractor like this. So starting from up here, we measure 25 degree. That is 25 there. Place a point there and then connect that point to point O. There you have it. Now, what is the distance? We say 400 kilometer, and we're using a scale of 1 centimeter to 100 kilometer. That means 400 kilometer is equivalent to 4 centimeter. So we are going to measure 4 centimeter from point O. Anywhere it ends, that gives us point X because the plane is going to point X. Let's use a different color there. This is 4 centimeter. Place a cardinal point there on the 4 centimeter. Then it's 4 centimeters right there. And that is point X. And from point X, this aeroplane change its course and fly 700 kilometers on a bearing of 80 degree to point Y. So from this point, let's remove this extra line first and extend this right line. So we can take our measurement from there. We're measuring 80 degree from that line, 80 degree right here, and connect that to point X. Okay, now from point X to this point Y is 700 kilometer. Based on the scale, 1 centimeter is 100 kilometer. That means 700 kilometer is 7 centimeter. Let me extend this line a bit too. So we have up to 7. Now let's measure it. 7 centimeter end here, right here. This is a little. That's okay. Again, we'll put a cardinal point there also. So now that is point Y. Then we'll connect point Y to the starting point O. And there you have it. Now, what do they want us to calculate? They say using a scale of 1 centimeter to represent 100 kilometers, draw accurately the positions of the points which you have done. This is point O, X, and Y. Then find the distance of Y from O, Y from O, Y from O. See Y here, and this is O here, meaning we have to measure the length of this line. And that is 9 point. Let me turn the ruler like this so I can see it clearly. Okay, now to 10, 9.9, and thereabout. Okay, 10, let's take 10 to distance. Let's call it OY is equal to 10 centimeter. Now, based on our scale, 1 centimeter is 100 kilometer. Therefore, 10 centimeter will be 10 times 100, which is 1000 kilometers. So the distance of Y from O is 1000 kilometers. Then question C says find the bearing of Y from O. The bearing of Y from O. Y from O. Look at Y here. And to get the bearing from O. So this angle starting from north to this line has the bearing of Y from O. So with the protractor, we can measure that angle. Remember, measuring from north. That means we are reading this lower measurement. So based on what I have here, that is 61 degree. 61 degree. The bearing of Y from O is equal to 61 degree. And that brings us to the end of this lengthy class on bearing and distances.